Your dealership just quoted you $2,500 for a total steering rack replacement, but they are hiding a massive secret. Your car isn't actually broken. It is trapped in a software lockout designed to drain your wallet. I'm going to show you how a 10-minute digital reset saves you thousands today. They quoted her $2,400. A single mother in Ohio, two kids in the backseat, EPS light glowing orange on her dashboard, steering wheel suddenly stiff as a concrete block. The service advisor slid a repair order across the counter without blinking. Steering rack replacement, full labor, alignment package. $2,400. She almost signed it. She almost handed over money she did not have for a part she almost certainly did not need. And the reason I know that, the reason I can say that with complete confidence, is because I spent 11 years working inside automotive dealer networks, and I watched this exact conversation happen hundreds of times. So today we are going to go deep. We're going to talk about what Toyota's electronic power steering system actually is, how it actually fails, what a battery has to do with your steering wheel, and exactly what questions you need to ask before you let anyone touch your car. Because the difference between a $2,000 repair and a $40 fix is almost always just information. And right now, most people do not have it. Let's start at the beginning because this story actually starts in the 1990s, and it starts with a problem that was driving Toyota engineers absolutely crazy. Traditional hydraulic power steering, the kind that was standard on virtually every passenger vehicle for decades, works by using a belt-driven pump connected directly to your engine. That pump pressurizes hydraulic fluid, which flows through high-pressure hoses to a cylinder inside the steering rack, and that pressurized fluid is what actually does the heavy lifting when you turn the wheel. It is a clever system, and it worked well for a long time, but it had serious weaknesses. The pump runs constantly whether you are turning or not, which means it is always stealing power from the engine, always burning fuel, always generating heat. The high-pressure seals inside the rack and inside the hose fittings are under enormous stress every single time you drive, and over time those seals crack, harden, and fail. Power steering fluid leaks were one of the most common complaints across the entire industry throughout the 1980s and 1990s. Stained driveways, low fluid warnings, and eventually that terrifying moment when the pump runs dry and steering effort triples in an instant. Toyota looked at this and decided there had to be a better way. The engineering team began serious development of a fully electric power steering system in the late 1990s, and by the mid-2000s they were rolling it out across their mainstream lineup. The Corolla received it first in significant volume, followed quickly by the Camry, the RAV4, and eventually almost everything they built. The concept was elegant. Instead of a hydraulic pump driven by the engine, you replace the entire fluid circuit with a single electric motor mounted directly on the steering column or on the steering rack itself, depending on the application. That motor reads input from a torque sensor, which detects how much force you are applying to the wheel, and it provides exactly the assistance the system calculates you need at that moment. At parking speeds, it gives you maximum help. At highway speeds, it reduces assistance to give you better road feel and stability. It adapts in real time continuously based on sensor data. The benefits were immediate and measurable. No more fluid, no more high-pressure hoses, no more belt-driven pump, stealing horsepower at every RPM. Fuel economy improved. End quote. Engine bay complexity dropped. The failure modes associated with hydraulic seals essentially disappeared overnight. From a pure engineering standpoint, it was a significant leap forward. But here is where the story gets complicated. And here is where I need you to pay close attention, because this is the part that actually affects your wallet. An electric power steering system is not just a motor. It is a network. The electric motor is controlled by an EPS control module, which is its own dedicated computer. That computer talks constantly to the steering angle sensor, which tracks the precise rotational position of your steering wheel in real time. It communicates with the vehicle speed sensor so it can modulate assist based on how fast you are moving. It receives data from the main engine control module and in many configurations from the vehicle stability control system as well. All of these components are exchanging information dozens of times per second across the vehicle's CAN bus network, which is essentially the central nervous system of your modern car. Now, here is the critical thing to understand about all of this electronics. Every single one of these control modules requires stable, consistent voltage to operate correctly. The EPS module is particularly sensitive because it is managing a motor that draws significant current, and it is doing precision calculations based on sensor inputs that are measured in tiny fractions of a degree. When the voltage feeding this system becomes unstable, when it drops below the threshold the module expects, the system does not just slow down or become less accurate. It throws a fault. It logs a diagnostic trouble code. It illuminates the warning light on your dashboard. And in many cases, it partially or fully disables power assist as a safety precaution because a steering system operating on corrupted sensor data is genuinely dangerous. This is the battery connection that almost nobody in a dealership service lane will explain to you clearly. A weak battery, one that is holding a surface charge but cannot maintain voltage under load, can cause exactly the same dashboard warning and exactly the same loss of power assist as a failed EPS motor or a failed control module. The symptoms are identical from the driver's seat. The repair cost is not. A replacement battery for most Toyota applications costs between $100 and $200. A replacement EPS rack, depending on the model, runs from $800 to over $2,000 in parts alone before you add labor. If a service advisor hands you a steering rack estimate without first showing you the results of a proper battery load test, that is the first red flag. A load test is not the same as a voltage check. A battery can show 12.5 volts sitting in a parking lot and still collapse under the load of starting the engine or powering the EPS motor through a parking maneuver. Load testing applies a controlled current draw and measures how well the battery maintains voltage under that stress. It takes about 3 minutes, and it costs nothing at most parts stores. If the shop quoting you a $2,000 steering repair cannot show you a printed load test result first, walk out and get the test done somewhere else before you authorize anything. Now let me talk about the steering angle sensor specifically, because this is the component that generates the most confusion and the most unnecessary repairs. The steering angle sensor sits at the top of the steering column, and its entire job is to tell the EPS module exactly where the steering wheel is pointed at every moment. It does this using a series of magnetic or optical encoding elements that generate a precise signal as the shaft rotates. The module uses this data to understand vehicle geometry, to coordinate with the stability control system, and to calibrate the amount of assist it provides at any given wheel position. Here is what most owners are never told. This sensor has a calibration value stored in the EPS module's memory. That calibration tells the system where the absolute center position of the steering wheel corresponds to driving straight ahead. This calibration can be lost. It does not happen from normal driving. It happens when the vehicle's battery is disconnected or replaced, when certain diagnostic procedures reset the module's memory, or occasionally when a significant voltage event disrupts the module during operation. When the calibration is lost, the system does not know where center is. It cannot accurately calculate assist. In some vehicles, the safety logic responds by disabling assist entirely and illuminating the warning light. The calibration procedure to restore this is called a steering angle sensor zero-point calibration. It is a real, documented, manufacturer-approved procedure. It is performed using a professional diagnostic scan tool connected to the vehicle's OBD2 port. The tool communicates directly with the EPS module and walks through a reset and relearn sequence that takes between 5 and 15 minutes depending on the vehicle. Many Toyota and Lexus models also require this calibration anytime the steering rack is replaced, the steering column is removed, or wheel alignment is adjusted significantly. It is not a secret procedure. It is in the service documentation. But it does require the right tool and the knowledge to use it correctly. Here is why this matters for your wallet. If your EPS light came on after a battery replacement, after a jump start, or seemingly out of nowhere without any prior steering complaints, the first diagnostic step should always be a scan of the EPS module's fault codes followed by a battery load test. If the fault codes point to a calibration loss or a communication error rather than an internal motor failure or a sensor hardware fault, the repair path is completely different from a rack replacement. A calibration service at an independent shop should cost somewhere between $50 and $150. That is the entire repair if calibration is genuinely what is needed. The problem is that a dealership service department operating under flat rate billing has a financial structure that rewards larger repair orders. This is not a conspiracy, it is just arithmetic. A service advisor who writes a $2,000 steering rack replacement earns more commission than one who writes a calibration. A technician paid flat rate earns more hours on a rack replacement than on a scan tool procedure. This does not mean every person in a dealership is dishonest. Most technicians are skilled professionals doing their best in a difficult industry, but the structural incentive toward larger repairs is real, documented, and worth understanding when you are sitting across from someone explaining why your perfectly functional steering hardware needs to be replaced. So here is what you actually do when that EPS light comes on. First, do not panic and do not authorize any repair on the spot. Ask for a printed diagnostic scan showing the specific fault codes stored in the EPS module. Ask to see a battery load test result. If the codes indicate a calibration issue or a voltage-related fault, ask explicitly whether a calibration procedure has been attempted before any parts are recommended. Get the estimate in writing and take it with you. Then call 2 or 3 independent shops that specialize in Toyota vehicles and describe the exact fault codes. Compare what they say. In many metropolitan areas, there are independent shops with the same professional diagnostic equipment as dealers, offering the same procedures at significantly lower labor rates. And if you want a second opinion on a part, look up the OEM part number for your specific steering rack on Toyota's own parts website. Compare that to what the dealer is charging. Markups of 40 to 60% on parts are common in dealership service departments. An independent shop sourcing the same genuine Toyota part direct will frequently beat the dealer price by several $100s on the part alone. The woman in Ohio, the one I mentioned at the start of this video, she did not sign that repair order. She called her brother, who called a friend, who told her to get a battery load test first. The battery failed the load test, catastrophically. $163 later, new battery installed, EPS, light off, steering assist, fully restored. Car drives perfectly. $2,400 problem. Solved for $163. That is not an unusual story. That is a pattern, and the only thing standing between you and that outcome is knowing what questions to ask before anyone touches your car. If this video saved you money or gave you information you needed, share it with someone you know who drives a Toyota. Not because I need the views, because the next person sitting across from a service counter with that repair order in front of them might not have anyone to call. Be that call for someone else. Subscribe if you want to keep going down this road, because next time we are going to talk about something that is going to make transmission shop owners furious. There is a specific adaptive learning reset built into virtually every modern automatic transmission that service manuals instruct shops to perform after any fluid service, and almost none of them do it. And the result is that thousands of people drive away from routine transmission services experiencing shift quality that gets progressively worse over the next several weeks and eventually return to pay for repairs that would have been completely unnecessary if one 5-minute procedure had been done correctly the first time. That video goes up next. Make sure you are there.